Before we get started, we're going to review some algebra concepts. In this first example, in order to solve for x, we need to undo what's happening to x. Well, we have x plus 3. The inverse of plus 3 is minus 3. Addition and subtraction are inverse operations. And as long as I subtract 3 from both sides of my equal sign, I can keep equality. Same with example 2. I have 4 times x. The inverse of multiplication is division. And as long as I divide both sides by 4, I can keep equality and solve for x. I want to keep that idea going in example 3. I have tangent of x equals 0.5. So I need to solve for x by getting rid of this tangent. Now, if you look, it looks like x is being multiplied by tangent. But x isn't being multiplied by tangent. X is being tangented, which is a word that I just made up, but it makes sense. This is not tangent times x, this is the tangent of x. So in order to undo tangent, we need to find the inverse of tangent. Well, the inverse of tangent is simply the inverse tangent. So I need to inverse tangent the left side of my equal sign and inverse tangent the right side of my equal sign. When I inverse tangent, these two operations undo each other. Much like addition and subtraction and multiplication and division, these two operations are inverses. So I'm left with, on the left side, just x. And on the right side, I have tangent inverse of 0.5. Now to figure out how big tangent inverse of 0.5 is, I'm going to use my calculator to approximate that answer. On my calculator, wherever I have the tangent, I'm going to also find the tangent inverse. On my TI-84, it's right above my tangent key. So if I hit second tangent of 0.5 and end my parenthesis, I can find the decimal approximation, 26.6. Now if we look back, if you remember, this value right here was always my angle. So when I solve for this x, I'm actually solving for the angle in my triangle. So x in this case is approximately 26.6 degrees. We're going to use this skill to solve the triangle. Solving a triangle means this. Find all sides and find all angles. Well, to find all sides, I already know two sides. So to figure out this third side, I'm going to use the Pythagorean theorem. Question mark squared plus 16 equals 14 squared is 196 minus 16. Question mark squared equals 180. Take the square root of both sides, and I'm left with question mark equals the square root of 180. Well, now I need to find the biggest perfect square that divides 180, and that is 36. So I can rewrite 180 as 36 times 5. So my missing side is exactly 6 square roots of 5 long. So I found all three sides, 6 square roots of 5, 4, and 14. Now I need to find all my angles. Well, angle C is already 90 degrees. I have that figured out. I need to figure out angle A and B. So to do that, I'm going to label the sides of my triangle. 14 is my hypotenuse, and if I go back to angle A, 4 is the side opposite of angle A. Now I could use this side, but I want to stick with integers. If I look at A, I have opposite and hypotenuse. Opposite and hypotenuse tell me to use sine. So sine of A equals my opposite side, 4, over 14. Once I have this ratio set up, I need to solve for A. Now I don't want to cross multiply, I don't want to divide, I want to get rid of this sign. To get rid of this sign, I need to do the inverse of sine. So I'm going to inverse sine both sides of my equal sign. Inverse sine of sine, these two operations undo each other. I'm left with just A equals sine inverse of 4 over 14. Now I can use my calculator to approximate my value for A. Again, second sine gives me sine inverse of 4 over 14. I get approximately 16.6 degrees. So A is about 16.6 degrees big. So my last value that I need to figure out is angle B. Now when I look at angle B, I can use any trig ratio that I want, but I want to stick with the trig ratio that involves these two integers. So if I look at angle A and this side right here, this side is actually adjacent to angle B. And the hypotenuse is 14. So the trig ratio that I want to use is adjacent over hypotenuse cosine. Cosine of B equals 4 over 14. Now again, I need to solve for B. To solve for B, I'm going to undo cosine by using cosine inverse. Cosine inverse of cosine undo each other. I'm left with just B equals the cosine inverse of 4 over 14, which is approximately, use my calculator, second cosine gives me cosine inverse, 4 over 14, 73.4. So B is about 73.4 degrees big. Now if I look at my answer, A and B should be complementary. 16.6 plus 73.4. Now, the fact that these two angles are complementary is a good way to check your answer, but make sure you're doing the trig to get your answer.